Jannah and Raf are in the study room, 30 minutes right before the MET test.
Since we are going to have a little test in a while, let me give you a slight introduction regarding CFRP, or we also known as carbon fiber reinforced polymer. Okay. CFRP also referred to carbon fiber, carbon composite, or just a carbon, usually made by carbon fiber, which is blended in resin, usually epoxy, to produce a light and strong material. So do you understand what I'm explaining now?
Maybe I will understand truly if I look into my notes.
Okay, I'm going to go to washroom for a while. I'll be back in a minute.
Okay.
After Jannah left the room, Raf looked at her notes so intensely and realized an unknown voice echoing. And in that moment, Raf lifted her head up and she bumped into a mysterious person.
Raf, can you hear me?
How did I end up in here? Who are you?
Hello Raf, I'm Carbon. Nice to meet you. We are your little brain cells who stand at you to score your MET test. Let's not waste our time and I will explain to you. What is carbon fiber reinforced polymer or CFRP? CFRP is a composite material that is made up of carbon fiber that is embedded in a polymer matrix, typically the epoxy resin. Next, how do the carbon fiber and epoxy resin work together? Carbon fiber acts as a reinforcement composed of thin filaments carbon atoms, typically have a diameter about 5 to 10 micrometers. These carbon atoms are bonded together covalently in a hexagonal lattice pattern and form graphene sheets, and this arrangement in a crystalline structure show an exceptional strength and stiffness. Meanwhile, epoxy resin works as a polymer matrix consisting of repeating units in which oxygen atoms link carbon atoms in a three-dimensional network. Epoxy resins are widely used as a polymer matrix due to their excellent mechanical properties, chemical resistance, and ability to form a strong bonds with a carbon fiber. The last one is how the CFRP was manufactured. During the manufacturing process, the epoxy resin is impregnated into the carbon fiber fabric to fill the voids between the fibers. Once cured, the resin acts as a binder to hold the carbon fiber together and transfer the loads between them. This is your ticket to your estate.
Somehow, the moment Raf took the ticket, she ended up in a library.
Hiya! I'm so excited for our journey today because I'm going to explain to you about the behavior, mechanical, electrical of CFRP. Please go ahead, enlighten me. Of course. In terms of behavior, CFRP has a quasi-isotropic property, meaning the even alignment of the fibers in the layout. The fibers are oriented to different degrees and provides its own specific properties. 0-degree layers provides axial strength and stiffness for columns. 90-degree layers maintains the stability under pressure. Positive 45-degree layers enhance torsion and shear resistance. Electrically, CFRP has low conductivity due to its insulating properties. The direction of the current flow depends on the fiber alignment. Higher conductivity is observed along with the fiber direction, while perpendicular alignment significantly reduces conductivity due to the helical carbon fiber structure. Mechanically, CFRP exhibits high modulus and tensile strength due to the combination of carbon fibers and the resin matrix like epoxy, which binds the fiber and transmits the loads among them. This causes the resin to have an excellent strength and stiffness, making the CFRP highly resistant towards deformation. I'm so sad that our journey ends here today. It's okay, you still have 2 stations left to visit. Here's the ticket to the next station. Thank you. Okay, bye.
Suddenly, Raf ended up sitting on a high chair. I wonder who she will meet this time. Let's see, shall we?
Reinforced, that's what people call me. I don't want to waste our time because for me, time is money. There are several advantages and disadvantages that I want to share with you. Let's take a look. Carbon fiber reinforced polymer CFRP is highly valued for its excellent strength-to-weight ratio, exceptional tensile strength, and stiffness, making it significantly lighter than steel and aluminum, while offering superior energy absorption and seismic performance. Engineers can customize CFRP properties during manufacturing to enhance specific structural areas such as bridge columns, improving load-bearing capacity and flexibility. CFRP also resists fatigue well, making it ideal for applications like wind turbine blades, bridges, and aircraft parts. CFRP is highly durable and resistant to corrosion, unlike steel, making it resilient to environmental elements like moisture, corrosion, and chemical exposure. It has low electrical conductivity and high resistance to humidity and salt water. However, CFRP's high initial cost due to the expense of carbon fibers, resins, and manufacturing is a significant drawback. The production of carbon fibers from fossil fuels have substantial environmental impacts, contributing to climate change and releasing harmful petrochemicals. CFRP also poses risks due to its brittlleness under certain conditions, potential for localized damage, and issues with machining and cutting, which can compromise structural integrity.
Here is the ticket for your next station. Thank you.
Ralph took the ticket and this time she ended up in an even more cooler place, the auditorium.
It's freezing here. Hey, you must be Polymer, right? I cannot predict from the full name of CFRP, Carbon Fiber Reinforced Polymer.
Hi Raf, that is correct. I am Polymer and this is your final destination of your journey. I'm here today and I will be talking to you about the recent scientific works of CFRP.
This may be your last station in the journey of CFRP, but this station is as important as the others, so please pay attention to what I will be sharing to you. Due to its exceptional properties, CFRP has been applied in various industries such as aerospace, automotive, and wind energy. Therefore, many researchers are taking this chance to study more about what CFRP can offer. One of the recent scientific works by researchers is making a battery using CFRP as the coating on the electrodes. This is done by using a silk-slide process to produce a CFRP-coated composite batteries that are protected from corrosion and are easier to handle. Another recent work is CFRP is used to produce a material that has a combination of strength, density, and stiffness that is similar to metals with low density used to create the hull of submarines. This helps minimizing costs of producing advanced submarines while maintaining the safety of the crew within the submarine. I have given you 2 examples of what CFRP has to offer. However, there is more to what CFRP can offer in the future, since there are many more research being conducted towards CFRP.
And that is all from me. That was a long explanation. Last question. Do you understand fully about CFRP?
Honestly speaking, I understand the whole concept of CFRP. It's like ultimate material, strong, light, and resistant to all sort of things,
making it perfect for things like planes, car, and even building. One of the coolest things about CFRP is that it stays strong no matter which way you pull or push it. Engineers can arrange the carbon fiber layer in different ways to give it special properties. It's like customizing your favorite gadget. CFRP also has some awesome advantages. It is strong than steel but much lighter, so it is great for making fast car and sturdy airplane wings. Plus, it doesn't corrode, so it lasts a long time. But it is not perfect. CFRP can be expensive and tricky to make, so it is important to weigh the pros and cons before using it. Exciting new research is showing even more cooler use for CFRP. Scientists are combining it with battery to make lightweight energy storing material, and they also using the built super strong submarine hull that can withstand harsh ocean conditions. All in one, CFRP CFRP is a game changer in engineering. Its incredible properties are already making a big impact, and as more industries start using it, the demand for CFRP is set to be so ready to see more this fantastic material in future.
I'm so glad you understand. This means that this is the end of the journey. My duty ends here. Bye-bye.
Huh? What do you mean?
There's echoes in the auditorium asking Ralph to wake up.
Ralph, wake up.
What noise is that?
Ralph, wake up. Stop daydreaming, we're going to be late for test.
It was a big dream. Anyways, let's go before we miss the test. Let's go.
Ralph realized that this whole time, she was just daydreaming. And they moved out from the study room quickly. The end.